The LMF technology can be used to establish and verify optimal torquing patterns. In this example, we'll look at data from 6 bolts on a SAG mill shell line. While there is no uniformly agreed upon torquing pattern, a very common one in this arrangement would be to tighten the middle ones and then the corners as shown here. Middle, middle, corner, corner, corner. Using a tablet, the reline crew can easily monitor the tensions of the bolts during installation. Here we'll see the tension of the bolts right after the impact wrench. The percent represents the percent of minimum yield strength. When the torquing begins, we'll pay particular attention to the first middle bolt, which initially is brought up to 68%. As the tightening continues, for instance, as the next middle one is tightened, you can see that the 68% drops down to 62%, and this trend continues as each bolt is tightened. After torquing each bolt, there was tension, however, it was not uniform. This customer explored what would happen if they did the pattern a second time at the exact same torque settings. It really only took a minute or two because the bolts were already tight, and it clearly achieved acceptable results, which were then used on the rest of the mill. Here is a graphical view of the exact same data. The first bolt was tightened to 68% and is represented by this gray line. We can see that as the 5 adjacent bolts were tightened, the gray bolt relaxed 5 times. After the second pass, all of the bolts were retensioned to acceptable limits with an acceptable spread.